Technology is constantly changing and evolving, becoming faster, smaller, smarter, and more efficient. But in this case, let me tell you that my close friend had suffering stomach ache. But he told me that he's scared to undergo next procedure, which is need to endoscope to see the imaging of the inner surface of his stomach and large intestine by using a fiber optic video endoscope. It need to be manually pushed through organ. The endoscope requires cable and makes him feel very uncomfortable. So suddenly I think, what if I can help him by undergo an explorative procedure without all the cables and physical connection, and my research is about link budget of normal mode helical antenna in implantable application. An example of implantable application that suit to this situation is wireless capsule endoscopy, WCE. WCE is a procedure used to record and detect any abnormality image of gastrointestinal tract in form of capsule. The gastrointestinal tract organ is mouth, esophagus, stomach, small intestine, large intestine, rectum, and anus. But first, what is helical antenna is? Based on 10th edition John Wiley and Son 2008, helical antenna is an antenna consisting of a conducting wire wound in the form of a helix. In the most cases, helical antenna are mounted over ground plane. The feed line is connected between the bottom of the helix and the ground plane. It also can operate in two principal modes, which is normal mode and axial mode. Normal mode of broadside helix, the dimension, diameter, and the pitch of the helix are small compared with the wavelength. The antenna acts similarly to electrical short dipole and monopole, while the radiation pattern similar to this antenna is omnidirectional with maximum radiation at the right angles to the helix axis. The radiation is linearly polarized parallel to the helix axis. These are used for a compact antenna for a portable and mobile two-way radios. So, to make clear of the link budget of normal mode helical antenna, I need to determine and improve the propagation equation of the link budget and MHA to see it is suitable to be used inside and outside of the body. I also aim to stimulate and the calculation of the link budget parameter by using electronic simulator. My main focus is a link budget for normal mode helical antenna in wireless capsule endoscopy application. Its characteristics were simulated to assess its performance within, inside, and outside of human body. Link budget is a calculation of all gain and losses from the transmitter through the medium to receiver. However, to ensure that link budget equation is accurate, not only link budget calculation is important as it ensures the system have enough signal to operate correctly. The link budget equation is modified from the general equation of the link budget for wireless communication system according to wireless capsule endoscopy system. This is to ensure that the link budget equation is accurate. However, this equation is not finalized. What software that I'm gonna use is, I will be using Phaco electromagnetic simulator. For your info, Phaco software consists of two parts, which is CAD Phaco and Post Phaco. CAD Phaco is used to set up and design the problem, whereas Post Phaco is used to visualize and compare the measurement with the simulation result. Thus, in this research, CAD Phaco is used to design a model of phantom and wireless capsule endoscopy inside the phantom. Then, I will designing the setting desired value of link parameter in CAD Phaco. After that, any users can simulate the design by using Phaco solver. In other hand, Post Phaco will show the result in various forms such as radiation pattern, near field, polar plots, and depends on user setting. Hence, in this research, Post Phaco will visualize this result of link budget in the form of graph. Lastly, the results from the simulation will be comparing with calculation from the theoretical analysis. The results from the simulation must be same to calculation in theory. However, if the results are not equal, the equation of the link parameter and the value for parameter need to improvise. Thank you for watching.